Salam structure to Tozawazi. Today I, Ong with my teammate David Han, Yong and Chang will present about the longest job first scheduling algorithm and we from group 4. Before we start the presentation, let me introduce the longest job first scheduling algorithm. The longest job first scheduling comes under the categories of the non-primitive scheduling algorithm. This algorithm mainly keeps the track of the boot time of all processes that are arise at the arise time itself, and then it will assign the processor to the process having the longest boot time. In this algorithm, once a process starts its execution, that it cannot be interrupted in between its processing. Any other process can be executed only after the assigned process has been completed its processing and has been terminated. This scheduling is similar to the SJF scheduling algorithm, but in this scheduling algorithm, the priority is given to the process having the longest boot time. Although this scheduling algorithm is not considered to be an efficient way of scheduling the process because there are many drawbacks of it. The first one is the Khor effect is displayed by it. The second one is this algorithm have a very large average turnaround time and average waiting time. Due to the effectiveness of the system decrease and processing becomes low.
The advantages of this LJF algorithm are the longer processes are executed first. It will not increase CPU overload, and the processes can be finished approximately at the same time. However, for the disadvantages, the average of waiting time and turnover time are high, the throughput is decreased, and it can lead to the convoy effect and suffer from the starvation.
Source code. For the first page of the source code, it contains try and catch block to catch invalid input from the user, such as alphabet value. First, the program will ask the user to input the number of process, and there is a if loop in the while loop to catch the user when the input of the number process is 0. So it will ask the user to input the number of process again. Then the program will ask the user to input the arrival time and the burst time according to the number of process. There is a for loop, and it will display a table that contains all of the data from the user input. And there is a for loop inside the for loop, which means it's a nested for loop. It is used to store the data and calculate the completion time. There are two for loops in this page of source code. The first for loop is used to calculate the turnaround time, waiting time, total turnaround time, and total waiting time. The second for loop is used to display all of the data, which includes number of process, arrival time, burst time, completion time, turnaround time, and waiting time. In this page of source code, there is a if loop inside a nested for loop. This loop is used to sort the data and arrange them in an ascending order. In this page of the source code, there are two for loop here. For the first for loop is used to display the data after sorting, and the second for loop is used to display the save sequence. At the last, there is a while bracket loop again. This loop is for a user who input an invalid data, and it will loop the whole process from the beginning. Output. This is the output of the source code. So first, it will ask the user to enter the number of process, and then it will ask the user to input the arrival time and the burst time, and it will display the data that include process, arrival time, and the burst time. It will display all of the data after the calculation, and then it will also display the list of data after sorting and will display the save sequence.
This is the discussion section. First is the procedure used in longest job first scheduling algorithm. Initially, the algorithm arranges the processes in ascending order of arrival time. Then, processes with the highest burst time is selected among all processes that have arrived up to that time. After that, the duration of the given burst time is being processed. The algorithm will check if there is any additional processes arrive until all the processes are being executed. Lastly, all the steps are repeated until all the processes are being executed. Take note that if there are two or more processes have the same burst time, the first come first serve scheduling algorithm is used where the process that arrives first will execute first. Next is the calculation part. To calculate the turnaround time, we have to use the completion time to subtract the arrival time. While to calculate the waiting time, we have to use turnaround time to subtract the burst time. To calculate the average waiting time, we have to use the waiting time divided by the number of process. In conclusion, we can say that longest job first scheduling algorithm is the most suitable to assign the CPU to the process with the longest time consuming. However, it is not suitable for the processes that must be prioritized and short time consuming, as longest job first algorithm will always run the longest time consuming process first. Therefore, to ensure the CPU performs efficiently, a good CPU scheduling algorithm is required.
At first, the system is asked to insert the number of processes, and followed by the arrival and burst time of the processes. After insert all the time of the processes, we can create a Gantt chart using longest job first scheduling based on the table produced here. We can determine the completion time easily with the help of the Gantt chart. And here is the table shows the turnover time and waiting time after calculation by using the formula. The average turnover time is 8.5 and the average waiting time is 4.25. And the last table shows the result after sorting the average time of the processes using longest job first scheduling algorithm. And lastly, the safe sequence of this algorithm was P1, P3, P4, and P2.
In my case, I passing 4 processes to the CPU to execute. P1 will arrive at millisecond with 2 unit of boost time. Process 2 will arrive at 1 millisecond with 1 unit of boost time. Process 3 will arrive at 2 milliseconds with 6 units of boost time, and lastly process 4 will arrive at 3 milliseconds with 3 units of boost time. So let's start to see what happened in the CPU scheduling. So at t equals 0, there are only one process available that have 2 units of boost time, so the P1 is selected and it will execute for 2 milliseconds. P1 is arrived at 0. Alright, after that at t equals 2, after the P1 is get executed, there are P3 and P4, but boost time of P3 is more than P4, so the P3 is selected and will execute for 6 units of boost time. Alright, after at t equals to 8, after the execution of P3, there are left P2 and P4, but in this case the boost time of P4 is more than P2, so P4 is selected and it will execute for 3 milliseconds. And lastly, left P2. So P2 arrived at time 11 milliseconds. So there is the process and the Gantt chart of the LJF algorithm. So in this LJF algorithm and from the Gantt chart, we can determine the completion time, turnaround time, and waiting time for each process. So at process 1, it complete at 2 milliseconds. At process 2, it complete at 12 milliseconds. At process 3, it complete at 8 milliseconds. And lastly, process 4, it finish at 11 milliseconds. And turnaround time. As you know, to calculate the turnaround time, we can use the formula completion time minus their arrive time. So at P1, turnaround time is 2, because 2 minus 0 is 2, same as process 2. Turnaround time is 11, P3 is 6, and lastly P4 is 8. And waiting time for each process, as you know, waiting time can use the formula turnaround time minus their boost time. So for process 1, the waiting time is 2 minus 2, using is 0. The waiting time of other process is same as process 1, using the formula waiting time equals to turnaround time minus boost time. So second process is 10 waiting time, and process 3, 6 minus 6, 0. And last process 4, 8 minus 3 is 5. Okay, from this table we can determine their total turnaround time, average turnaround time, total waiting time, and their average waiting time. To calculate total arrival time, just summation all the 4 of the turnaround time using 2 plus 11 plus 6 plus 8 is equals to 27. and average is use 27 milliseconds divided by number of process, which means 4, so it's 6.75 milliseconds. And total waiting time, sum of the waiting time, this column, which is 0 plus 10 plus 0 plus 5 is equals to 15 milliseconds. And average time is same as turnaround time, is use 15 divided by number of process, so we get 3.75 milliseconds. This is the end of my example of LGF scaling algorithm. Thank you very much.
Here, I have prepared a list of data, includes process, arrival time, and for the burst time. Now, I will demo how to calculate the completion time, turnaround time, and the waiting time. First, before the calculation, in the calculation, we must draw a Gantt chart to show the completion time and for the safe sequence. In this scheduling algorithm, the priority is given to the process having the longest algorithm. In these 5 processes, the priority is given to the process that have the longest burst time. So at t equals to 0, there are 2 processes are available. The first one is process 1 and the process 2. But for the process 2, the burst time has the longest compared to the process 1. So the process 2 will execute first. So after execution of the process 2, there are available processes to execute next. There are P1, P3, P4, and P5. As we know, we choose the process that has the longest burst time first, so P4 will execute. And then P1, and then P5, and for the last one is P3. Value below the Gantt chart is completion time. What is completion time? Completion time is the time taken of a process to finish the execution. So for P2, is the arrival time is 0, for the burst time is 6. So this is 0. It finished execute as 6 milliseconds. And for the process 4, it's the same, 6 plus 5 equals to 11. And for process 1 is 15. And for process 5 is 18. And for the last process is 19. After we finish fill in the completion time, next is to calculate the turnaround time. Turnaround time, the formula for turnaround time is completion time minus arrival time. So for the first process is 15 minus 0 is 15. 6 minus 0 is 6. 17. 10. And 15. Waiting time. The formula for the calculation waiting time is turnaround time minus burst time. So this one is 11. This one is 0. This one is 16. This one is 5. And this one is 12. So that's all for the calculation. And this is the Gantt chart. The Gantt chart is used to illustrate the process execution. So the safe sequence is P2, P4, P1, P5, and last one P3. That's all. Thank you.
This is the second demo of the algorithm. First of all, I'm required to enter the number of process. Then, I have to enter the arrival time and the burst time for each process. The first table shows all the value I've entered just now, and the second table shows the calculation, which include the completion time, the turnaround time, and the waiting time. After that, it will show the total turnaround time, which is 35, and the total waiting time is 22, while the average turnaround time is 8.75 and the average waiting time is 5.5. And the third table shows the sorting based on the longest job first scheduling algorithm. The process 4 will be executed first, followed by process 2, process 1, and process 3. The safe sequence is P4, P2, P1, and P3. This Gantt chart illustrates the execution of the processes based on the value I've entered just now using longest job first scheduling algorithm.